So in this case here, we've been given the angle side. So if I were to draw this, I have angle A is 54 degrees. So I'm going to draw about 54 degrees here. Let's say that's angle A. Side B is going to be the adjacent side. Okay, so we'll call that 12. Side A is going to be 10. So I can draw side A, which is opposite to angle A, and that's a length of 10. Okay, so that's one way I can draw this triangle. Now, there is an alternative way I could draw a different triangle given the exact same information. And I'm going to draw it separately over here. So this is going to be my 54 degrees here. A side length of 12. Okay, so exactly the same. But instead of drawing 10, the side length of 10 going out this way, I could bend it back this way. Okay, so let me just draw this a little bit nicer if I can. Okay, so there's my side length of 10. And this exact same information, but now in this case, we have two different triangles. So again, in this angle side case, there are two possible triangles that can be formed given this information. And we have to number one, recognize it and then solve this. So again, we have this only occurs for sine law, and sine law is when we have angle opposite side pairing. So yeah, we definitely have an angle and opposite side pair. And we have to be able to then solve for the rest of the two angles and the third side. So I'm going to set this up solving for this triangle here in black. So I'm going to use my angle, so the sine of the angle over the length. And again, we're using sine because we have to translate that angular measurement into some sort of length measurement, and we do that through sine. And that's equal to, and this is going to be angle B here. We'll call that C. We'll call this C2 actually. C2, B2. Okay, so if I solve for this here, I get sine of angle B2 over 12. Actually, this is going to be B1 actually, so my mistake. We'll call this B1 and C1. So when we solve for this, we end up with 12 sine 54 degrees divided by 10 is equal to the sine of angle B1. Okay, working out the decimal of that sine value, we get 12 times sine 54 degrees divided by 10. Okay, it's 0.9708, so I'm going to round that to 971. So sine B1 is equal to 0.971. Okay, so then solving for angle B1, okay, we're going to use the arc sine of this, so we're going to undo the sine. So I want to get in the habit of writing the arc sine. Okay, so input is the angle, the output is input is my ratio, the output is my angle. So I do second sine, and I get, oops, so I get 76.12 degrees. So angle B1 is equal to 76.12 degrees. Okay, so I get, okay, so taking a look at B2 at this point here, angle B2 and angle C2, angle B2 really is just the supplement of angle B1, because this angle in here that is not part of the triangle is the same as the angle that was solved. Okay, so there's my 76.12 degrees. To find my angle B2, this angle, obtuse angle here is 180 minus angle B2. And again, it's the exact same issues that theta 1, theta 2. when we undo the sign in the circle. Okay, so then angle B2 is equal to 180 degrees minus theta 1. It's the exact same formula. And we get theta 2 is equal to 103.88 degrees. Okay, and that allows us to solve for C2. Okay, angle C2 is going to be 180 minus 54 degrees as well. Okay, so angle C2 is 22.12 degrees. Okay, so angle in this triangle, the angle up here we call C1. So angle C1 will do the same thing. It's going to be 180 minus 22 minus, in this case, 76.12 degrees. It's going to give us 81.88 degrees. Okay, so this angle in here is 81.88 degrees. This angle up here in this triangle is going to be 22.12 degrees. Okay, so there we've solved for the three angles of that triangle. We just need to solve for the third side now. So that's side C1 here, and that would be called C2 over here. Okay, so solving for C1. So side C1 over sine of 81.88 degrees is equal to, and I use my original side opposite angle pairing. Okay, so side length C1 is equal to 10 times the sine of 81.88 degrees divided by the sine of 54 degrees. Okay, so the length of C1 is 10 times sine 81.88 divided by sine 54. And I'm getting 12.24 approximately. Again, you're rounding, depending on your rounding, you may be a little bit off, but that's okay. 12.24. Okay, so there's my side, there's my angle, and where's my other angle here? So there's my two angles that I solved for, and my third side that I solved for. Okay, I have to do the same thing over here. I've already solved for my two angles. Okay, I just need to solve for my third side, so I'm going to use my sine law, C1 over C2 over sine of 22.12 degrees is equivalent to the original sine ratio, angle and opposite side pairing, so 10 over sine 54 degrees. Okay, so I'm just going to highlight that again. Oops. It's going to be my angle and opposite side pair. There it is. Okay, it's the same as the one that we used over here. Okay, this is the same one that we used over here. Okay, those are all the same. The relationship holds true in both triangles. So I end up with solving for my C2 length. So C2 is equal to 10 times sine of 22.12 degrees divided by sine of 54 degrees. And the length of C2 works out to be, so 10 times sine 22.12 divided by sine 54, and I'm getting 4.65. Okay, the length of 4.65, and whatever units that is, we'll just call it centimeters. 4.65 centimeters. Okay, so there it is. So I've solved for all three unknown parts of both triangles. I have to recognize this is an angle side-side situation, so there is this issue of ambiguous case, meaning two possible triangles to solve for.